Good morning, folks, and welcome to our terrestrial navigation session. We're still paying a little bit of attention to the exact schedule, so there may be a small schedule change later on, so stay tuned. We're going to figure that one out shortly. But for now, I just want to introduce our first speaker, Andrew Dempster. Professor Andrew Dempster is the director of the Australian Centre for Space Engineering Research in the School of Electrical Engineering and Telecommunications at the University of New South Wales. He has a BE and an MNGSC from UNSW, University of New South Wales, and a PhD from the University of Cambridge in efficient circuits for signal processing arithmetic. He was a systems engineer and project manager for the first GPS receiver developed in Australia in the late 1980s, and has been involved in satellite navigation ever since. His current research interests are in satellite navigation receiver design and signal processing, areas where he has 6 patents in new location technologies. He is leading the development of space engineering research at ACER. Welcome, Professor Dempster.
Good morning, everybody. I've been told to stay near the mic, not wander around, which is what I normally do, so that the recording remembers what I say. So I have to stay here. Right. Okay, good. You're looking at that, and you're going, oh, that looks pretty boring. Lawyers. What have I got up at 9 o'clock in the morning to listen to? Okay, I'll try and make it as interesting as possible. I've got a lot of material here. I'll probably try and skip the less interesting parts. But this is something new that we've been working on. I've got a couple of other colleagues. The talk today is going to be based around 3 papers that we've written. The first 2 have been presented. The third one is still in preparation. Interestingly, we're sort of finding that this work, if you're thinking about GPS data as evidence used in court, it's not really something that we're finding that the technical people are interested in publishing in journals. But the lawyer there, Gary Edmond, is an evidence lawyer, so his research is in evidence, and he's saying that this is definitely the sort of thing that we can publish in journals on the law side. So we've got a 4th paper also lined up for Pacific PNT, which is arising out of some of the work done by an undergrad, which I'll talk a little bit about later. So when you talk about the law and satellite navigation, in the early days, it was more about liability. So, you know, if this airline is using GPS to land and the GPS fails and the aircraft crashes, who's the liability? And particularly in the early days, that was one of the arguments that Galileo was using to justify its existence. You know, we're a civilian service. We can provide us a recognised level of service, and so that was sort of early days of GPS in the law. Then we came across cases where there were just mistakes, and so you know, police came into the wrong house. They used the coordinates of the house to go in. The wrong house was repossessed, and there were extreme cases where, in fact, the wrong house was demolished. They turned up with the GPS coordinates and just smashed down the closest house to the coordinates they had, which just happened to be the wrong coordinates. Now, when I say recent, so there's been a recent study. You can see there's 2015. It was done in the US, and the undergrad I mentioned, Solange, she's working on a similar sort of thing for the Australian courts. And of course, a lot of this stuff is very jurisdiction specific. So, you know, I made some statements when I presented this at ION about, you know, the behaviour of expert witnesses, and people were saying, no, that's not how expert witnesses behave in the US. And I would imagine in various European jurisdictions it's different as well. So, where possible, I'll be trying to generalise, but you get the general drift. If it works in Australia, something similar will work elsewhere. But that study there, 2015, you can see there were 19 different criminal and 11 different civil classifications of case. So it's this GNSS data is really coming into a broad spectrum of cases, but it's not being used as critical evidence. So the prosecution or the defence tends not to rest solely on the GPS data, except in 8% of cases. Admissibility is something which is different across jurisdictions as well, and admissibility is something which we as a group are going to look at more in the future. What's sort of exercising or motivating me really at the moment is this issue of quality. How trustworthy is the GNSS data you're using? And sort of the what do they call it, the elevator pitch that I've been using for this sort of discussion is we're probably 5 years away from a situation where two autonomous vehicles have a collision, there are no human witnesses. Which insurance company pays? So the insurance company is going to have to go back, and they're going to have to look at the data, and it's really that PNT data which is going to be most important. How fast were you going? Where were you? Acceleration, all those records need to be good, they need to be trustworthy, so that the two insurance companies can between them work out who pays. Now that specific example is not a particularly good example in the sense that, as we've heard yesterday and we know, the positioning of autonomous vehicles is not purely based on GNSS, and those blended solutions or integrated solutions are sort of something which we're thinking about in a second phase. At the moment we're just looking at the GNSS side, and we'll expand that out into cases like autonomous vehicles or mobile phones and whatever. But it's looking like it's already getting relatively complicated. So what are we trying to achieve? Well, I would like to come up with just some guidance for expert witnesses, so people who give evidence in court about GNSS data, which I have done, and I know Logan mentioned yesterday a case that he was involved with. In fact, he told that story yesterday, and when I heard that story before, it had elephants in it. It was a much more interesting story when you told it to me. You could have told them about the elephants. Anyway, and I spent a bit of time actually at that ION conference talking to people like Logan, other sort of mainly sort of people who are fellows of the ION, about how they've worked as expert witnesses in interesting cases. And virtually everyone who you talk to has a good story. Oh yeah, what about this case with the elephants? But ultimately what I want to do is be able to give some nice advice to expert witnesses, and also from the data logging side to come up with a way of logging the data in such a way that it gives useful evidence. Now, the undergrad I got working on this, like all good researchers, has gone off and found some new questions as well that she would like to raise. And one is, she's looking at all the cases that have GNSS data in them, but that have involved an expert witness, but she's coming up with cases where she thinks they should have had an expert witness but didn't. So we're looking at advising the court about when an expert witness would be a good idea, and what criteria you could use. So why am I doing this? Well, this is the motivating case that I had. Now I'll try and indicate to you. So what happens is, can we see this? Whoops, something happened. I'm going to try and use the arrow. Is the arrow up there? No. All right. I just need a pointer. Yeah, there wasn't one here a little bit back. Is there a laser? Okay. All right, I'll describe it. So coming along where the blue markers are there, into the region where the yellow markers are, you can see that there's a roundabout down there. So this is downhill. The yellow part is downhill. There's a roundabout at the bottom of the hill. We've got a petrol tanker. It goes around the roundabout too quickly, flips over, blows up, kills 2 people. Dangerous driving, causing death. So this vehicle was recording data in several ways. So the yellow markers, every time you turned the steering wheel by more than a particular angle, it would record the data and send it back. It would send it back every 20 seconds anyway, and there were various other things. The blue ones were recorded every second, gathered together into a big message and sent every minute. So it sent the message at that minute there, but the last minute was incomplete, so it didn't get that last series of data. So the police wanted to know, was this guy speeding down the hill? And the speed limit for heavy vehicles was 80 kilometres per hour. So you can see the marked speeds there. It looks like there's an 82 and an 86 towards the end. In fact, it looks like he's accelerating down the hill. Okay, so they asked me to look at this. And on this plot, the blue ones are the 1 second data and the green ones are the 20 second data. And it would appear that they are not consistent with each other. And so I went back to the manufacturer of the logging company and said, okay, how many GPS receivers you got on there? And they said 1. So all this data is supposed to be coming out of a single receiver. The best I could do to get it to match was that red thing there, which sort of looked like there was sort of a delay of 13 seconds, but I couldn't make the data match up. So I thought, okay, well, why don't I use position and time for those yellow ones to see if I can match the velocity data and see which of the two sets of data are correct. So then I came up with this, and you can see that we're getting in both, the one we're most interested in is the S's, which is just single segments, and then the A's are longer segments averaging over. You can see that A1 is not particularly useful because it's not following the road very well. But you can see it here, so the S's, we're actually getting over 100 kilometres an hour in that one. So using position and time to work out the velocity gave higher speeds and inconsistent speeds with both the previous sets of data. So there were 3 sets of inconsistent data here. And so I started to think, well, you know, people like me should be getting this data thrown out, or the defence should at least have someone who can look at this and say it's not really admissible because it's so inconsistent. So the questions, do we trust this stuff? And this, so this is the first time I've sort of presented all this stuff in a big thing. I'm not entirely sure I've got the narrative structure right. So there are sort of little bits will jump in from nowhere, like this. One of the things that, one of the other questions, or one of the things to recognise is that the GPS receiver or the GNSS receiver in these devices is being asked some questions. And the questions they're being asked are things like, where is it? How fast is it going? That sort of thing. Sometimes, what time is it? The expert witness is being asked different questions. Sometimes they'll be asked, oh, okay, is the driver speeding? But it's more likely you're going to be asked, on that day, at that time, how good was GPS? So that you can work out whether the data that we're working with is any good. So the cases that I've got there, I'm just sort of writing out the different questions that we're looking at. So, if our problem is trustworthiness of the data, where do the problems come from? So here we have GPS satellite, the receiver, and then down the bottom there, we get the data out of the receiver and we look after it. Or the police or law enforcement people look after the data in some way. So you can see there, also, the red things are all of our potential problems. So the system itself, GPS, might have some problems, or GNSS. Along the path of any individual pseudorange, you can get ionospheric and tropospheric problems, attenuation, multipath. Between the satellites, you can have poor geometry. In addition to the GPS signals, you can have spoofing and jamming. If you're using some sort of corrections, like differential corrections or RTK, then you'll be getting some sort of input from elsewhere. That data can be doctored. The stuff that goes into the memory can be doctored. And then once you've extracted it, the evidence can be tampered with. And so far, we've come up with 11 questions that you can ask. Now, that example I was just talking about, I'll just go back to that, comes under this other errors bit, right? Sort of frustrating area which is difficult to put your finger on what the actual problem is. So here are our 11 questions, and so they're about the GPS system, the ionosphere and troposphere, multipath, attenuation, jamming and spoofing, geometry, calculation and storage, any other information, possibly from other sensors also, and was the data extracted and presented as evidence without being modified? Now, when you go out there and look for this sort of thing in the literature, questions 1 to 10 are not really covered. Question 11 There's quite a lot on digital forensics. There's not very much on GNSS forensics. And by complete fluke, when I was at the ION conference this year, the guy who does most of the law enforcement officer in the US who does most of the training of law enforcement people on GNSS forensics happened to be at the doctor in Miami at the time, and so we were able to meet up, which was a very useful meeting. So he could tell us all sorts of stuff about this 11, but all those others are of interest. And that's where I think the expert witness comes in. Some of this stuff, it's a different type of expert witness who can look at the digital forensics, but it's the GPS person or GNSS person who can look at those earlier questions. Okay. Now, there's a couple of sets of criteria here that are used in courts. This Dober standard is looking at how valid an expert witness's evidence is, and they think about, has the technique in question been tested? So this standard has been brought up for instance, fingerprints or DNA or something like that. That's the thing, the sort of type of thing they've got in mind when they're asking these questions. Has it been tested? Has it been peer reviewed? Is there an error rate? Is it well controlled? And is it accepted within the scientific community? So I guess in the GNSS case, you might think that, I'm going to come to integrity later, maybe integrity is where you want to be thinking about integrity calculations, would be the sort of thing that you would apply this standard to. And then in digital forensics, has the meaning and interpretation of the evidence been unaffected? So these are criteria that are applied really pretty much to the back end. I'm going to sort of not spend too much time on these slides, basically because there's lots of stuff on it. That's an example which I don't think I need to go through. So in my work on this, I rang up the guy who's actually the top space law professor in Australia and said, oh, look, what do you know about GNSS evidence, what's out there? And he said he doesn't know about anything. But the remote sensing community have got to the point where they've even written a textbook on it. So we as a community have certainly not been as productive in this area as our colleagues from the Earth observation community. So there's the textbook. It's got lots of chapters, and what I did was I just went through and sort of read through this thing to see if I could learn any lessons. Now, because it's a space-based system, the Earth observation system, a lot of their agreements are generated out of the UN, and there is a sort of an agreement, or the ICG is the sort of representation of the GNSS community under that UN banner. And they talk really about, with Earth observation, it's whether a particular nation state is observing another nation state, whereas GNSS is quite different. The types of issue we have here are more to do with individual people, vehicles, whatever. So the analogy is not as close as you might want it to be. But some of the general principles apply. So if you're saying, okay, I'm looking at this field and that field is corn, you send someone out to have a look at it and say this is corn, which means you can then infer that other similar fields throughout the Earth observation data are corn. GPS or GNSS data can be authenticated in a different way, and again, I'll show some examples of that a bit later. The idea of self-authentication, again, you might be thinking about integrity when you're thinking about that. So yeah, at UNSW, I presented some of this work to the group of my evidence colleague, a bunch of lawyers, and I was going through this stuff, and I said, oh yeah, look, in Earth observation community, they say all this evidence is being produced by a machine. There's no human really involved in it, and this is silent witness theory. Could you just explain silent witness theory to me? And they said, never heard of it. So that wasn't a particularly useful conversation, so I can't explain to you this, but then neither can the lawyers. So let's not worry too much about it. this authentication, they call it ground truthing, and to some extent we do as well in this community. The use of this sort of technical data in courts, and certainly in the Earth observation community, there's an obligation for the expert to educate the court. That responsibility is also relevant here. You can pretty much guarantee that the court, in other words, the judges, the lawyers on both sides, a jury, if you've got a jury, will not understand GNSS, will not even know the relevance of those 11 questions, and so really it's up to the expert witness to make sure that the court is educated on that. So part of this guidance that we would be producing for expert witnesses would be about how an expert witness could help educate the court about these things. What are the important things that can be understood simply that affect this evidence? Okay, so another example that I have from my own experience is this, this case, Robert Turnbull, again from 2014. This was a murder case. What happened was an environmental officer was driving up and down this road with a GPS receiver. In the property that he was driving around, the accused was burning some trees, or cutting down trees and burning them against the environmental requirements, so he was breaking the law by doing this. The environmental officer was photographing this to use as evidence himself, and Turnbull just came out and shot him. The question, I think, I was never fully informed about why they were asking about this GPS evidence. My guess is that in this area up here, where the numbers stop, was where, and the question might be asked, was the environmental officer trespassing when taking the photographs? I'm not even sure why that was a question, murder's murder, so... Anyway, so you can see he's driving around, and again, I've just numbered those points sequentially. So this was a very simple example that everyone will get about how I was able to say, yes, I'm quite trusting of the data that's come out of this receiver. So I'm probably the only person in the room, maybe, I don't know, who drives on the left-hand side. So what's happening here, right? You can see the numbers go 21, 22, 23 going up the page, and then on the other side of the road, 42, 43, 44 coming down the page. So if you look at that data, just referring it to itself, right? As the vehicle goes up the road and comes back down the road, in a relative sense, it's in the right place. So this is sort of authentication, corroboration. Then, in addition, when you overlay it on a Google map, and we all know that Google Maps, Google Earth has some geo-registration problems, but you can see in this case it's not too bad. So in an absolute sense, it then fits on the road. So we're on the road, we're on the right side of the road, sequentially the data makes sense. Also, if you look at this, I don't know if any of you have been to sort of the outback of Australia, there's nothing there, right? It's flat. Our multipath situation here is pretty benign, except for reflections from the ground itself. So, because the data was very well behaved and it was exhibiting behaviour, it exhibited behaviour that allowed me to say, okay, yeah, I'm relatively confident of the quality of that GPS. Okay, privacy again. So this was just another one of these things that the Earth observation people looked at. Means a different thing for GNSS. Again, more to do with the individual. Let's just skip that. And I think we can probably not worry about this, except as the sort of textbook, the Earth observation textbook, progressed, there was more emphasis on digital signatures, and we saw yesterday, I mean, quite a lot of what Logan and some of the other speakers yesterday had to say is quite relevant here. So when he was talking about watermarking and so on, the authentication of the GPS or the GNSS signals themselves is one way of avoiding some problems. Particularly, he was talking specifically about spoofing, but in general, in this area of evidence, that sort of authentication is also useful. 2 minutes. 2 minutes. How can I have 2 minutes? I started late. Yeah, that's right. My GPS timing. Anyway, right, let's get going. Okay, let's actually forget that. Right. I'm interested in doing something similar. Right, 2 minutes. Okay. I'm not going to explain integrity to you because you probably get integrity. So I'm assuming that you all understand integrity from yesterday. I'd put some material in here just to explain it. But what it allows us to do is identify individual measurements that have been affected by multipath. It can be used for detecting jamming and spoofing and stuff as well. Some logging formats, like NMEA, the sentences you get out of NMEA give you some information, but not really enough to help very much. There's a bit on geometry and so on. There are other messages that they have, like the residuals for each satellite and so on, but these messages are not used very often. Some of the other logging formats, like GPX, don't have anything at all in there to do with integrity or signal quality or position quality. The Android phones, if you've got those raw measurements, you can make some of those integrity measurements yourself. And if you look at some of the standards like ADS-B and AIS, they both have some sort of integrity indicator, but really quite primitive. So in the AIS case, you really just get, is the protection limit 10 meters or more or less? So it's a binary thing, 1, 0. And ADS-B it gives you a number, but that's it. You don't get much other information. So here are the 11 questions. The paper that we're writing at the moment is covering is about the filling in of this table. We've got the 11 questions. How do you answer the question? Can you access some information that helps you do it on a question by question basis? Now, if you've got some sort of corroboration or authentication, even simple authentication like that example I showed, it bundles a number of these questions together and say, okay, I can not bother about those questions. Some of the ones down the bottom are quite independent. Some of the questions can be answered inside the receiver, and we saw some of these techniques discussed yesterday, how a receiver can detect spoofing and jamming, multipath. These are sort of well-known techniques, but the receiver in general does not tell you that that's happened. I've detected multipath on this signal, or I have not used this satellite because it was experiencing a bad multipath error. Something like that. So that's the sort of thing that we'd like to get into this standard that we're hoping to write for loggers. So the receiver can detect a whole lot of things, including integrity, the receiver autonomous integrity monitoring. And the integrity gets you around some of these questions as well. So what we're looking to do is to come up with this advice for expert witnesses, which would be a checklist along the 11 questions. And sort of the advice would really arise out of that, that table. Then work out this recommendation for a logging standard, where that standard, or the body that would produce that standard, we're not sure who that might be yet. We certainly know that the ION has said they're not interested. And then, even if you've got something that's quite simple, that you're able to then take to the court and say, this GPS evidence is good, this GPS evidence is bad, or this one is somewhere in between. And I think I've mentioned some of the work that my student is doing, that we need further advice for the court. And I also mentioned we were looking at admissibility. So admissibility is a sort of, it's a more technical legal investigation that we've been needing to do there. But that brings me to the end relatively, whoops, let's not go to the extra slides, relatively on time. Okay.